We've talked so far about the median. We've talked now about the lower and the upper quartile and what they mean. Well, now let's focus on the entire 5-number summary. When we talk about mean and standard deviation, which we've talked about so far, that's typically when we're talking about symmetric data. What if our data is not symmetric? Okay, what if we have some skewness to it? This is typically when we're going to use our 5-number summary. Our 5-number summary is simply going to be these 5 numbers. Our 2 quartiles and our median, numbers that we found so far, our minimum, the lowest value we have, and our maximum, the upper value that we have. I'm going to use these numbers and I'm going to make myself a box plot. A box plot is simply stated just going to be a picture with a box in the center, 2 lines on the side, where I have my minimum, my first quartile, my median, my third quartile, and my maximum. So all it does is it takes this 5-number summary and it gives us some visualization. In a modified box plot, it's essentially the exact same thing as a box plot, except it's going to cut out all the outliers. And we'll talk about how to find the outliers in 1 second. So the picture might actually look like this, where this is my minimum. I have my first quartile, my third quartile, my median, and this point here might not be my maximum, because I might have a point that's way out here that's my max. But this point out here might be an outlier. It might not fit within the general scheme of the data. So then this point would be the first data point that is not an outlier. So it will be the largest point that is not considered an outlier. Let's look at a data set. So if we look at this data set, first thing we're going to do is we're going to find the median. There it is right in the center, 18. Now we're going to break our list. We're going to find our first quartile. We're going to find our third quartile, my minimum, my maximum. So my 5-number summary is going to be 13, 16, 18, 24, 28. If I wanted to make a box and whisker plot, or a box plot we call it now, first thing I'd do is I would make my box, which is going to be 16 to 24, using my quartiles. You don't have to worry about scaling this, but the fact that 18 is a lot closer to 16, make it somewhat realistic. 28 is relatively close, so we won't make a really long whisker. 13 is relatively close, so we won't make a very long whisker. And now I have a box plot. So this is just a visual representation of that. How do I decide if there are any outliers? Well, the first thing I have to do is I have to find my IQR, my interquartile range. So I take my 24, I subtract my 16, and I find my IQR to be 8. Now, how do I find my outliers? Well, simply stated, you take your first quartile, you subtract 1.5, which is a set number, times your IQR, in this case 8. So what I'm going to do here is I'm going to take 16, I'm going to subtract 12, and I'm going to get the number 4. 1.5 times 8 is where the 12 came from. 16 is my first quartile. I'm going to do the same thing up top with the third quartile, except I'm going to add the 1.5 times the interquartile. So I'm going to take the 24, I'm going to add 12, and I'm going to get 36. This 4 to 36 is basically what we're going to say to our, quote, acceptable region. And that's a gray area there. What we're saying is any values that fall between, any data that falls between 4 and 36 is not considered an outlier. Anything outside of that would be. So let's go to this data set then. Same data set. Okay, nothing changes about it. I still have my 18. I still have my 16. I still have my 24. But I changed the end number. So now I'm focusing on 38. Well, if I find my IQR here, it's 24 minus 16. We just found that to be 8. Well, when I took 16 and subtracted 1.5 times 8, I took 24 and I added 1.5 times 8. I ended up with 4 to 36. Well, look where 38 falls. 38 is outside. So 38 is what we consider to be an outlier. So now I'm going to make my box and whisker plot, but I'm going to make a box plot that is modified. I'm still going to use the 16. I'm still going to use the 24. I'm still going to use the 18. The box is never going to change. 13 is okay. There's nothing wrong with 13, so I'm not going to change this whisker at all. But now 38 is an outlier. So I'm going to work my way back in my data set to the first number, the last number on the end here, that's not considered an outlier. So this is only going to go out to 27. But I still have to include that 38. So this would be a picture of a modified box plot. The modified box plot, just like a box plot, the difference is it clearly isolates and indicates that there are any outliers. Little summary here. 5-number summaries typically used when we're talking about non-symmetric data. Box plots and modifieds are very similar. In fact, they're exactly the same if there's no outliers. The only difference is the modified separates the outliers. And how do we determine the outliers? By using your quartiles and your interquartile range.